Lipids, trialkaloids, and fatty acids. Formations of trisaccharides. Reaction glycerol plus 3 acids equals trisaccharide plus 3H2O. Bonds. Ester bonds formed via dehydration synthesis. Breakdown. Hydrolysis. Addition of water to break ester bonds. Types of fatty acids. Saturated, no double bonds, carbon-carbon only. Single bond. Straight chain, tightly packed, solid at room temp. Sources are like butter, animal. X increases LDL, heart disease risk. Unsaturated, one or more double bonds. King structure, liquid at room. Types of monosaturated, one double bond. For example, olive oil, avocados. Polyunsaturated, multiple double bonds, for example, omega-3, omega-6. The effect lowers the LDL, increases HDL, which is good cholesterol. Trans fats, created by partial hydrogenation, unsaturated to saturated fat. Increases LDL, lowers HDL. Processed foods, margarine. Omega-3 and omega-6. Omega-3 has the first double bond on the sixth carbon in vegetable oils. Difference between cis and trans bond. Cis, hydrogen atoms on the same side of double. Trans, hydrogen atoms on opposite sides, straight structure like saturated fat.
Fluid mosaic model. Fluid. Phospholipids and proteins move laterally, flexible, and self-healing. Mosaic. Membranes has phospholipids, proteins, cholesterols, and carbohydrates. Next one. Membrane components and functions. Phospholipids form bilayer, hydrophilic heads, face water, hydrophilic tails, face inward. Integral proteins. Transport, signal reception, enzymic activity. Peripheral proteins, structural support signaling. Cholesterol regulates fluidity, prevents solidifying in cold, excess movement, and heat. Glycoproteins and glycolipids, cell regulation and signaling. Next one, membrane fluidity factors. Unsaturated fatty acids increase fluidity. Kinks prevent tight packing. Saturated fatty acids decrease fluidity, tight packing. Cholesterol stabilizes membrane, reduces fluidity and heat, increases in cold. Functions of membrane proteins. Next one. Transport proteins move substances across the membrane. Example, channels, carriers. Enzymatic proteins speed up chemical reactions. Receptor proteins detect and respond to chemical signals. Cell recognition proteins help immune systems identify cells. Carbohydrate and protein breakdowns. Hydrolysis. Why water is essential. Hydrolysis requires water to break down bonds of carbohydrates and proteins. Without water, digestion cannot occur. For example, carbohydrates, starch with HTO, is the glucose. Proteins. Protein HTO is amino acids like pepsine, trypsin, and the example of the enzyme is amylase for carbohydrates plus starch was HTO. Steroids, waxes, and phospholipids. Structure. 4 fused rings of carbon. Hydrophobic and insoluble in water. Functions. Cholesterol. Maintains membrane fluidity and stability. Serves as a precursor for other steroids. Hormones. Cholesterol regulates stress response and metabolism. Regulates reproductive functions and secondary sexual characteristics. Controls salt and water balance in the body. Crucial for calcium absorption and bone health. Waxes. Structure. Long chain fatty acid plus alcohol. Characteristics. Hydrophobic, solid at room temperature. Functions. Waterproofing. Found in plant cuticles, bird feathers, and human skin to prevent water loss. Provides a barrier against environmental damage. For example, earwax prevents debris from entering the ear canal. Energy storage. Some marine organisms use waxes for long-term energy reserves. Phospholates. Structure. Glycerol plus 2 fatty acids plus a phosphate group. Characteristic. Amiphatic, hydrophilic head, hydrophytic tails. Functions. Cell membranes. Main component of biological membranes forming the lipid bilayer. Empathetic nature. Hydrophilic phosphate head, fatty acid tails enable selective permeability. Cell signaling. Phospholate. Derivatives play roles in signal transduction. Example, phospholate in cell signaling pathways. Other key concepts. Fat versus fatty acid. Long hydrocarbon chains with COOH group building blocks of fats. 3 fatty acids attached to glycerol. Acidic properties of fatty acids versus fats. Acidic due to the free COOH group. Trisaccharides. Neutral. Acidic properties lost after acidification. Why are steroids important? Essential for cell membrane stability, hormone production, immune response. Bad reputation, misuse. Example, anabolic steroids lead to health risks / health liver issues. Why can't small ions diffuse through a plasma membrane? Ions such as chlorine, potassium, sodium cannot diffuse directly through the plasma membrane despite their small size because charged and hydrophilicity. These ions are charged and interact strongly with water molecules, forming a hydration cell. The plasma membrane is composed of a hydrophobic lipid layer which repels charged particles. Membrane composition. The inner region of the membrane, fatty acid tail, is nonpolar and does not allow charged ions to pass. This prevents ions from diffusing through small unchanged molecules. Example, oxygen, CO2. Alternate transport mechanism. Instead of simple diffusion, ions require specific protein channels, felicited diffusion, or active transport to cross the membrane. Example, sodium, potassium, pump ion channels, and carrier proteins. Molecules used for active transport and faster transport methods. Molecule used for active transport, ATP, provides energy for active transport. Fast methods of transport than diffusion. Facilitated diffusion uses protein channels for fast movement of molecules. Example, glucose transport. Active transport moves molecules against a concentration gradient, low, high, using ATP, e.g. NAK. Endocytes, engulfing large molecules to vessel. Exocytes, releasing the substance via vesicles. What happens in a multi-gated channel? Multi-gated channels open and close in response to changes in membrane potential, voltage differentials across the membrane. Resting state. The channel is closed at a normal resting state potential. Minus 70 MV in neutrons. Depolarization, opening. When the membrane becomes less negative, example 55 MV, the channel opens. This allows specific ions, example sodium, potassium, and calcium, to move across the membrane. Repolarization, closing. Once the membrane returns to its resting potential, the channel closes to stop ion flow. Example, volt-gated Na channels and neutrons open during action potential, allowing Na to rush in and prorogate nerve signals. Concept map. 4 major functions of membrane proteins. Transport proteins facilitate the movement of molecules across the membrane. Channel proteins create a passageway for specific molecules. Example, aquaporins for water transport. Carrier proteins bind to a substance and change to move across the membrane. Example, glucose transporter. Enzymatic proteins speeds up chemical reaction at the membrane surface. ATP synthesis produces ATP in mitochondria by facilitating proton movement. Digestive enzymes break down nutrients in the small intestine, e.g. lactase for lactose digestion. Receptor proteins. Functions detect and respond to chemical signals from the external environment. Examples. Insulin receptor binds insulin to regulate glucose uptake. Neurotransmitter receptors bind to neurotransmitter receptors like dopamine or serotonin to transport nerve signals. Cell recognition proteins. Function helps cells identify and communicate with each other, playing a role in immune responses. MHC, major high compatibility complex. Proteins help immune cells distinguish between self and non-self. Lysoproteins allows cells to recognize each other and communicate. Quick review. Dehydration synthesis is removal of water to build molecules. Hydrolysis. Addition of water to break molecules. Saturated fat. No double bonds. Solid at room temp. Unsaturated. One or more double bonds. Liquid at room temp. Trans fat. Unnatural fat created by hydrogenation. Increases heart disease risk. Essential fats. Omega-3/fatty acids. Omega-3/6 fatty acids. Essential fats with first double bond of 36 carbon. Fluid mosaic model describes membrane as dynamic and diverse. Integral protein. Embedded in bilayer. Transport signaling. Peripheral protein. Attached to the surface. Support signal. Cholesterol regulates membrane fluidity, and glycoprotein, glycolipids, cell regulation, and signal.